Hello, welcome back. For the last 5 to 6 sessions, we took you through some of the noise and vibration tools and their application areas. And when we were explaining a lot of instrumentation that are associated with, we thought we should put up a demonstration setup to show how these look like, how these are configured, and how do they work. In today's session, we will take you through a full arrangement of this demonstration. Kindly watch. So before we begin this demonstration, here is a quick look through of the transducers. So here is a uniaxial accelerometer, a small one, and we have the low G sensor with two varying sensitivity. This is a 1000 millivolts sensitivity. Then we have a miniature transducer and a piezoelectric again, followed by the side mount type uniaxial accelerometer. This is a triaxial accelerometer for modal application. Industrial accelerometer, you can see them. Some of the noise transducers here are type 1 half an inch microphone, and we have a 1/4 inch microphone here, then a sound level meter with a preamplifier, a calibrator to make calibration measurements. Then we move to data acquisition. You can see a 2-channel analyzer, a 4-channel data acquisition, a wireless based National Instruments acquisition, a 8-channel LMS system, and then moving on a Siemens 12-channel system, extremely portable. Then we have NI 16-channel and beyond. We also have a 32-channel system. So you will be able to see some of these today in session. This is a signal transducer. This is another signal conditioner. We have a laser-based tachometer, a stroboscope, and much more.
Hello all. Here we have made a demonstration setup where a microphone and an accelerometer are configured around a rotating motor. Motor as a representation of a rotating body, and a uniaxial accelerometer is mounted onto the motor body near the front bearing part with a mounting pad that is pasted onto the body using a glue or an adhesive. And there could be other mounting methods like stud mount, magnet mount, and drill tap mount, for example, and sometimes even a handheld mounting. And this is connected to a microdot cable that will finally go to a signal conditioner and then to the data acquisition system. This is the type 1 microphone. As you can see, there is a windscreen there which may not be required for this purpose, but I need to show you this, that this will be very useful in cutting the moving air and the air passing through it. And this is a class 1 or a type 1 microphone, and this is a uniaxial accelerometer, and now both will be connected to the data acquisition system. But before connecting to the data acquisition system, we generally want to use a signal conditioner in between, which is also an ICP power supply. Incidentally, many of the data acquisition systems may have the ICP power built in, but we tend to use in many of the consulting to use it as a buffer and as an isolation, because this helps in a good quality of data. This is a 3-channel signal conditioning unit, and 3 individual channels could be connected that would further be connected to a data acquisition system. And also here I have some more instrumentation that are usually alongside used. These are accelerometer and microphones, and here I have got a stroboscope which is not used anymore, but this is very useful when you do some balancing in a little older methods. And you have a triaxial accelerometer here, good high temperature and shock tolerant, and then you have got a half an inch free field microphone. This is a laser tachometer that could be used alongside the vibration measurement whenever you have balancing or whenever you need to track phase and RPM measurements. And then we also use impact hammer wherever there is a structural testing that you induce force into the system and tend to take both the force input and the vibration response. And these are the tips that you use alongside, softer or harder tips depending on your usage. So moving on, here is the LMS 8-channel portable SCADAS data acquisition system with additional inputs of 2 tachometers and 2 outputs for generating random and other signals. And it has a single module of 8 channels that's plugged into the mainframe and can be used for many dynamic data acquisition But there are other new variants of these data acquisition system as well. This is a brand new acquisition that we have. This is from Siemens, the erstwhile LMS system. And here you can see 4 ports or 5 ports, but 4 ports are for this 3 channel into 4, which is making it 12 channels. It has got a GPS, CAN bus unit and ISP DIF also. And it's an excellent portable battery operated with a long onboard memory. And also here is an equivalent one or a good one in different sense. This is a 4-channel National Instruments data acquisition system, and it has a plug-in module, which means that you can remove this and put one other module, maybe for strain measurements. The best part of this module is that it has a Wi-Fi connection, so you can configure this to work with the Wi-Fi network, and it will become a lot better technology-enabled data acquisition system whenever you want to make an autonomous measurement. And this is the noise calibrator having 94 and 114 dB calibration values. The microphone to be calibrated is inserted into the cavity of this calibrator, and the output is measured to validate its correctness. The data acquisition system, here you can see this is a front end which has got 8 channels, and there the 2 lights that are glowing indicates that the 2 channels, one from noise and one from vibration, are configured. You can also configure more channels there. So this is connected to a software suite where you can see the time data being monitored at this moment, but a lot of other measurements can be done. Of course, Ethernet being the port or the USB being the port. The speed of the data transfer always depends on the USB and the Ethernet speeds. And nowadays even you have these Giganet Ethernets as well. And you can also see, other than the time data, the FFT data are coming up here, and also you will be able to see a lot of other settings, and you will be able to see the octaves here, which are typically for sound measurements and the noise measurements. And a lot more information could be gathered for post-processing and analysis. So overall, this small description of noise and vibration transducers being configured and the overall setup made to make measurements and then record this data and use this for a number of post-processing of data to analyze, to infer, or to interpret the data is all possible.
So in this demonstration, we could show you a live setup where noise and vibration instrumentation are configured and how the measurement comes up for the software platform. In the next episode, we will try to plan and show you a time data acquisition combined with a good amount of data processing and how all these setup are made to understand the data. Till then, take care and bye.